TD information with 500 kHz of bandwidth, it's a little bit tricky. So we have to find a better way to synthesize the frequency and to cover the whole bandwidth. The second big invention of the beginning of the 90s was the SDR. What is SDR is exactly the same thing than the direct conversion receiver. That means we are using a local oscillator very close from the receiving frequency, but we are extracting two different signals from the antenna. That means the direct signal and the same signal shifted 90 degrees compared to this one. That means the same signal with two different time difference. This one is a little bit earlier than this one. Why? Because with this system, well, that's the next one. Because with this system, we are able to extract two signals, the in-phase signal and the quadrature signal. With these two signals, we have a precise idea of the signal in the time. We are in the time domain analysis of a signal, not in a direct receiving system. This is a very simple schema of the former stage of the phase shifter. That means this is a very simple system with two operational amplifiers. That means that former radio receivers that were very costly, could be replaced with approximately $2 of components. Come back with the IQ system. Now that we have our two signals, the result of the demodulation schema could be done with a pure mathematical operation. This is an AM signal that we can decode just with the Pythagorean theorem. FM is this formula, pulse modulation is this formula. It means you don't need anymore a dedicated electronical system to decode an information. This system is fully software coded. We have begun with this kind of system. This is the SDR that costs less than $30. And able to cope. This one was a crystal based, but with the TDS, you have approximately exactly the same. If you want to see it later, you have approximately the same complexity of electronics. This is a receiver, a full receiver, able to cover from 150 kilohertz to 30 megahertz. The total cost is $40. So if you need a point of comparison, the USRP from HackitoErgoSum costs $1,200. That's not exactly the same stuff. That means you don't need a big gun just to read drops low bandwidth signals. That doesn't mean that the USRP is a bad receiver. The USRP is FPGA based and is able to deal with signals with more than 5 megs of bandwidth. This one is limited by to approximately 500 kHz of bandwidth. So that's not a big deal, but it doesn't cost a lot. This is another point important in SDR is once you have defined the mathematical equation that define your modulation, you can do exactly the same thing on the other side. That means you are able to transmit with the same reaction, with the same logic. Two signals here and here, I, Q. The phasing system with four parameters, and the mixer, the table we have seen on the third slide, and the power amplifier. That means every time you can you are able to decode an information. It means you are able to spoof the information or to eject. And it doesn't cost a lot. SDRs have been, well, more and more SDR. This is the first USRP using the GNU code, GNU radio. This is the Quicksilver one. There are approximately 15 years of technological difference between those two. This one is using an FPGA and several transverters which are plugged here. This one is direct system able to cover from 0 to 1 gig without converting, without converter. Those two are commercial systems, and this one is based on the former schematic diagram you've seen. That means the technology of this one is very simple. It's completely computer-based, and this one is CAN-based. And those are the different systems you can see there and here. The first prototype here has been built by a 5-people team dedicated to eavesdrops, TCL, the current-based transmission system, CPL en français. Because these information transmission systems are definitely not based on cable. These are radio systems. Very few people are aware that PLC are radio systems. With such a receiver, well, which is a